everyone, we're back. Sorry for the short little break, busy schedules. I'm sure you understand how it is. Well, I am presenting to you a math episode on exponents. I absolutely love math. My husband says I'm a math geek, but you'll kind of see his geeky side here in a minute too. Hope you enjoy.
This episode, we're going to be looking at exponents and some of the rules that you may not know or may not remember.
Alright, Miss Math Genius Lady, you tell me how it's done.
First, I think it's important that we look at what is an exponent. Here you'll see the base numbers are kind of like what we write as our normal numbers, and the exponents hang out on top. See here we have 2 to the third, 9 squared, 8 to the 5th, 5 to the 10th. But what does that really mean? An exponent means to take the base number or symbol and times it by itself the number of times noted by the exponent. So here we have 3 to the 4ths, which is the same as 3 times 3 times 3 times 3. A to the 9th is the same as having 9 A's multiplied together. 7 to the 3rd is 7 times 7 times 7. And z to the 6th is the same as z times z times z times z times z times z.
Okay then, Miss Smarty. How about this before I rip all of my hair out?
First, when you are adding or subtracting terms with exponents, you need to look at the base and see if they are similar or not. If the base is the same, then you add the bases together but leave the exponent alone. For example, 4x to the 9th plus x to the 9th. The bases are the same and the exponents are the same, so we're going to add the bases. 4x plus x is 5x and the exponent stays a 9. If the exponents are different, then do not combine the terms. For example, 4x to the 9th minus x to the 6th. Our exponents are not the same, so we're going to leave them separate, and it would equal 4x to the 9th minus x to the 6th.
What do you mean I can't do it that way? What? No! Ugh.
When you multiply terms with exponents, you leave the bases the same and add the exponents. For example, x to the 5th times x to the 4th, our base would still be an x, and our exponent would be 5 plus 4, so it would be a 9. We'd have x to the 9th. X squared times x to the 8th, the base would still be an x, and we would end up with an exponent of 16. X to the 3rd times x to the 3rd, we would end up with x to the 9th. When you divide terms with exponents, the bases stay the same unless there's a coefficient, and you subtract the exponents. For example, x to the 9th divided by x squared, our base would stay an x, and we would take 9 minus 2 and end up with x to the 7th. X to the 30th divided by x to the 10th, we would have a base of x, and our exponent would be 30 minus 10 equals 20, x to the 20th. X to the 14th divided by x to the 7th, we would have a base of x and a exponent of 7.
Okay, here's what I'm thinking. I think you have got me thinking.
If your base number has an exponent of 0, then the answer is 1. The reason for this is because a 0 exponent would be the same as subtracting exponents when you are dividing. For example, x to the a over x to the a would be the same as saying x to the a minus a, which would equal x to the 0. But if you think of it this way, x to the a over x to the a, that's a fraction. If your numerator and denominator are the same, then your answer is going to be a 1. When you have a base and an exponent that is taken to an exponent, then you multiply the exponents, leaving the base the same. For example, if we had x squared squared, we would multiply the exponents and end up with x to the 4th. If we had x to the 10th to the 10th, that'd be the same as saying x with our exponent being 10 times 10, ending up with x to the 100th. X cubed to the 7th would end up being x to the 21st. If your base has a negative exponent, then you need to move the base and exponent to the denominator if it is a whole number, or to the numerator if it is already a denominator, and make the exponent positive. For example, if we have x to the negative 3rd, it would be the same as saying 1 divided by x to the 3rd. If we had 1 divided by x to the negative 9th, that would be the same as saying x to the 9th.
I've got it. I get it finally. Thanks to your great expert explanation of exponents, I understand. Little background on this one. I was actually the one who suggested this because I was in a math class. I have math anxiety, so I have some trouble doing it. Jess, on the other hand, who was handling the mathematics stuff for you, she's great. She knows her stuff, and she actually helps me out quite often. So I definitely hope that she was able to help you. Hey, I hope you all enjoyed this week's episode. I'm sorry, I know we were gone for a little while there. We found out that making these was a little bit more time consuming than we had originally banked on, and we wound up pretty busy ourselves. So, but we're getting back to it. We're kind of working out things to where we can actually do this. Jess and I might not always be together in these just because of scheduling issues. We're both in school. She works, so we've just got a bunch of stuff to do. That's the way it works out. If you liked it, click the like link down there. Should be right down there. Yep, go ahead. And please feel free to comment. Thanks.